Możemy zacząć live. I teraz już, teraz już ludzie będą to widzieć.
To już następny to musiałbyś
Nie będę widzieć. Good morning, everyone. This is Maciej, and I would like to welcome you on the first day of Mythic 60/70 service training. So as a first thing, we will need to check the connectivity. So please let me know over the WhatsApp chat that you can hear me and see me well. And then we will carry on with the presentation about our products. Thank you for your confirmation. So if everything is okay with the quality, now we can carry on with the presentation. So as a first thing, usually we are sharing the introduction presentation. So this is it. So one more time, my name is Maciej Greszta, and I'm working for Cormay Diagnostics. And during this training, I will try to explain you what is the difference between Cormay, Orphy, and Cormay Diagnostics. So stay tuned, and I will try to explain this as best as possible. So in the background, maybe you can hear the noise because right now the Mythic 60 is sitting next to me, and I'm running the startup on this analyzer. So startup is still in progress, so we still need to have like a few minutes, and then the audio quality will be a little bit better. So stay tuned and wait patiently. And in the meantime, we'll start with this presentation also. Your contacts at Orphy. As a first thing, maybe you already know that we have one common email address for Orphy products, for hematology products. We also have a common email address for the biochemistry products, for the Cormay products. So if you want to, if you request any kind of support, at this point, we recommend to send us an email to support@orphymedical.com. And this email will be direct to all those people which are sitting in our, which are working in the international service department. So the first guy on the list is Michel Legrand. Some of you, if you already have some experience with the Orphy, you may know this this person, this gentleman. So he is our director, and he's working here in this company for many years. John Staniak is a second guy on the list, and he's working also with us for 8 years, I believe. Michał Szubartowski is working with us also for a few years. Łukasz Szymański, he is the new person in the company, maybe not in the company, in the international service department, because Łukasz actually has experience from the Cormay domestic service department, because he was working there in the domestic service team for many, many years. And the last guy on the list is Maciej. So it's me. Other contacts in the company, So what we have, the QC department. The previous email, this one, support at Orphe Medical, was actually, if you are requesting uh, a support with a technical problem with the analyzer, or you don't know what is the meaning of any particular error, or all those things, right? You can request a support by using this email. But if you know that your issue is related to the reagent, or it's related to the QC or calibrators, you can directly contact Michał Leśniewski at cormay.com. And he is a specialist who is responsible for communication with the customers in the QC department, right? QC is related to the reagents, controls, calibrators, not only for hematology, but also for biochemistry, all those things. Another contacts will be at the customer service department. So if you want to place an order for some spare parts, for reagents, for calibrators, all those things, you can contact the cs at cormay.com. Or if you already know who is your dedicated customer service person in our company, you can contact directly this person. But we have also one common email address, which is cs at cormay.com. So a few words about the Orphe itself. So Orphe is a Swiss-based company, and it was founded in 2002 in Geneva. And from the beginning, it was working with hematology solution. So I mean by that, those were analyzers, reagents, QC calibrators, dedicated for the hematology for small and medium-sized laboratories. Although right now we try to extend our portfolio, so in the future we should have in our offer some bigger analyzers, which can fit even into some bigger laboratories with a higher throughputs. But Mythic 70, which we have already in our offer, can deliver 70 samples per hour. So actually, this analyzer can fit also in some small hospitals if you only relying on the standard CBC and the diff parameters. And here we have another slide which is trying to explain what is the Cormay diagnostic. And actually you see that there is a direct connection between Cormay and Orphe. And for many years we have like two companies. And in practice, those two companies, Cormay is still here and Orphe is still here, but we decided to put them under one common brand. So more often you will see Cormay Diagnostics on some kind of marketing materials, but also Orphe or Cormay logo will be there. Because we noticed that some Cormay customer have no idea about the Orphe products, or they don't use Orphe products, and vice versa, right? So this was the thing. And by putting everything under one common brand, I think we are more recognizable as a one brand instead of two separate companies. Combining those two companies, Cormay and Orphe, together we have like a 35 years of experience on the manufacturing of reagents, and 35 years. You can imagine that this is outstanding knowledge about the biochemistry and also about the hematology reagents, because reagents for Orphe are produced by Cormay, basically in our factory. Mm, and this is the story, right? Cormay Diagnostic is basically one common brand, but still you will see in the documents two separate companies. Analyzers offered by Orphe. So on this slide we have some old analyzers like a Mythic 18, 18 for veterinary. This is Mythic 22 OT, and this is a veterinary products 5 diff Mythic 5VET Pro. So this is 5 diff analyzers with the reticular sites. Um, and on the next slide, we have slightly newer analyzer. This is still the old analyzer 22AL, so it's with us for many years already. But here is a Mythic 60. So this is the device that we will try to go with the presentation about this device today. And Mythic 70, which is actually a new version of the machine with the autoloader, 22AL, right? So Mythic 60 actually is a new version of Mythic 22 OT. You can basically describe this thing as a new version of Mythic 22 OT, and Mythic 70 is a new version of 22AL. So maybe you already know, but 22AL and Mythic 22 OT, they have some drawbacks, they have some problems. We've got some issues, we know about those issues, and actually this is the reason why the company developed new products, and those were Mythic 60 and Mythic 70. So I think this is a step in the good direction. Here are the few slides which are about the reagents. So we are not focusing on the 3D reagent. As you can see, this is Mythic 18 diluent lyse solution. And one thing which may confuse you, this cleaner, it has a name, Mythic 1822 cleaning solution, but indeed this is only for Mythic 18. This is not for Mythic 22 or Mythic 60. Why this name why this name is like this? Because on the beginning, when the company introduced the 5 diff products, the company was using the same cleaning solution, Mythic 18 /22 cleaning solution. But actually, over time, we noticed that this cleaning solution from Mythic 18 is not sufficient to clean the analyzers, the 5 diff analyzers correctly. So we switched to another cleaner and we introduced a new cleaner. But since this name was already registered by many customers, we need to stick to this name, and this name is still with us for those many years. But please keep in mind, this is only for Mythic 18, this cleaning solution, and 5 diff products, 22OT, 22AL, Mythic 60/70 will use those reagents. So diluent for Mythic 22, only one as a lyse solution, and cleaner for Mythic 22. So this is it. QC and calibrators. 3diff calibrators, 3diff QC materials. I will skip that because this is for Mythic 18, but 5diff, 3 levels, mid 5D normal level. Those are the calibrators, those are the QC materials which will be used on the Mythic 22 OT, AL, Mythic 60 and 70. Midcal, this is the one common calibrator for all those analyzers. And GCal, this is actually the calibrator special for optical bench, which allows us to correctly align the gains in the optical channel for Mythic 22 OT, 22 AL, Mythic 60 and 70. So please remember a few things about those QC and calibrators. When you are receiving the material, this should be stored between 2 to 8 degrees, so it should be stored in the fridge. And unopened vials, tubes, are stable through the expiration date. When you will open the vial, the shelf life is only 15 days for mid 5D. And mid-cal, unopened tubes and vials are stable through the expiration date, but when you will open the vial, it's only 7 days. And same thing for GCAL, 7 days. But from my experience, I know that the GCAL will last for longer. It's not that prone to be damaged. So basically, this material can be used for longer. Okay, I see that one of you has an issue. So if you have a problem with the video, with the quality of the video that I'm sharing right now, what you need to do is go to the web browser or on your wait, I will try to show you that. Wait. Okay, so actually, if you are seeing something like that, this is basically a problem with the quality or the streaming quality on your site. So what you need to do is simply just go to the settings and just choose full HD video, and at this point the video should be like that. Yeah, should be like that. This is what you should see. So try to do this on your site. The same thing can be done on the cell phone. If you are watching this on the cell phone or some kind of tablet, the same thing can be done. We are streaming in the full HD quality, so you should not have any issues on this side. Next slide. So in this slide, we are talking about the another very important thing, which is hypochlorite solution. Dometic 1822 flash cleaner. This is the solution that we that Orphe is producing. And actually, we only recommend to use this thing because any kind of domestically available flash or hypochlorite solution may damage your analyzer. With this flash cleaner, there is not such a risk, and this is the only thing that we recommend to use. And even if you are sometimes the customers complain about the damage to some kind of plastic components in the analyzer. And actually, when we will discover that the customer is not buying the flash cleaner from us, we're suspecting that there was a damage caused by the hypochlorite, which was sourced domestically by the customer. So in this case, we can even reject the warranty claims because we have a proof that he's not buying flash cleaner, and we are seeing that there is some kind of plastic damage or tube damage. This is basically clearly visible, and we know the signs of such a hypochlorite damage or different, different things damage. So please be aware of that. For the kit, for the latex material, what is actually the latex material? So the latex is actually a special material. In the vial with that, you have some small plastic polystyrene particles, and actually those polystyrene particles, they have specific size, right? So this specific size will mimic the appearance of the white blood cells and also can mimic the appearance of the red blood cells. So keep in mind that for M60, and 70, you will need to have kit latex M60 available on your site, because you will not be able to use normal kit latex or latex RBC PLT, because those are different materials. Latex WBC is the same thing, and it's in latex WBC is included in the kit latex M60, but also in this vial we have another vial with a latex RBC. So keep this in mind. As you can see, one vial of latex RBC and one vial of latex WBC, which is the same thing. So keep in mind that when you have Mythic 60 or 70, you need to purchase another latex material. And actually, this is very, very important to have this available on your site. And you need to use it during the installation, during the maintenance, during the repairs, if you are touching anything in the impedance channel or in the optical channel. Those are the use for this material. So this also need to be purchased. And you know, right now when the customer is complaining about some kind of problems with the results, we are also checking if customer has heat latex available, if customer has a calibrator available, if customer has a QC material available. And if those are not present, what I want to say is actually partially a fault of the customer that the material is not present, because at this point the customer is not able to make any kind of calibration, any kind of checks on the analyzer, and we don't know what is the exact status of the device, because the material which I mentioned is not available. So you need to have those available. You need to purchase them. You need to have them on stock available. Even if they will expire, you need to purchase another one, you know, and this should be available for you. Maybe not for customers all the time, but only for service engineer. So one of my recommendations during this training will be to make basic spare part stock. And this basic spare part stock will also have calibrators and latex materials. Okay, let's go to the Mythic 60. So in this case, we have 28 parameters, 60 tests per hour, and this is 5-diff hematology analyzer. What 5-diff means? This means that this analyzer can differentiate between 5 basic types of white blood cells. So those will be lymphocytes, monocytes, neutrophils, basophiles, and eosinophiles. Right? So this is the 5-diff analyzer. Although this analyzer can also report you two additional types or subpopulations of the white blood cells. One will be the atypical lymphocytes population. So during some kind of infections or disease, some lymphocytes, they become bigger and they are appearing in a slightly different position on the histogram, on the scattergram. So in this case, we are talking about the atypical lymphocytes. There is another possibility when the bone marrow is producing a lot of white blood cells in case of leukemia or in case of some kind of ongoing infections. We also can have a presence of immature white blood cells. So those are big white blood cells which are still not exactly neutrophils, for example, or eosinophiles, right? Because usually they will later mature and they will go to the neutrophil population. What else do we have here? Dynamic clustering. So this is a special software feature which is changing the position of the discriminators for the scattergram, but this can be done dynamically for each sample, for each patient. We still use the same set of 3 reagents plus flash cleaner. 3 reagent plus flash cleaner, right? So diluent, only one, and cleaner. And there will be also a hypochlorite solution, flash cleaner. The user interface is, it was renewed. It's more modern. We use the same touch panel 8.4 inch as present in the 22AL. We also have the pre-diluted or pre-dilution mode with automatic diluent dosing. Sampling volume is 15.6 microliters, and consumption of reagent is, in this case, is even lower than consumption of reagent in MITIC 22. We improve the fluidic system and electronic design, and we claim that 98.5% time this analyzer can be up and running and process some samples every day. For MITIC 70, I have a separate presentation, but I want to show you this presentation maybe tomorrow afternoon, because right now we will focus more on the 60. We will go through the service training presentation for 60 and also for the application presentation for 60. And the application part will be common with the MITIC 70. So basically, this is the reason why I want to keep this MITIC 70 for later. This slide needs to be updated because right now the orphymedical.com website is not longer present. So if I will open it, we will go to this new website, and actually this is right now the website where you can find all the informations which were present previously on the Cormay website and Orphe website, right? There were two separate websites. Right now we have one where we have all Cormay Diagnostics products. So this presentation is about the hematology, so let's go to the hematology and just go to the analyzers. And here we also can find information about the products that we have. Let's go to the MITIC 60. And what is the section which can interest you is actually documents. Yeah, documents. So what we can find here is a user manual and service manual. So user manual, I believe, is available only for login. After login, service manual, the same thing, but some kind of catalogs like those hematology catalog for our products. Hematology brochure. This is basically available for everyone, so everyone can come here and just take a look on our products. There's also some kind of leaflets for MITIC 60. Wait for a download. This is like a very big resolution PDF, so with a lot of pictures. So we have those informations like here, short leaflets, but like that. What else we can find here? We can find information about the calibrators which will be used with the MITIC 60. So as you can see, it's a kit latex M60, latex WBC, but MITCAL and GCAL. So for example, what we want to do is download the assay sheet for MITCAL for MITIC 60. We need to go to MITCAL later, and there is a table. So we simply just need to choose the MITIC 60 and we can download the PDF file. So here is the assay sheet for all analyzers, but also there is an application for MITIC analyzer. So this is special file which we will use later. To upload the information to the analyzer. And actually, this is nothing else. This is just a text-based file. So the software itself is taking those data and putting on the analyzer menu. So later I will show you that when we will work with the device. So this is the place where you can download all those things. For control, for mid-5D, the same thing can be done. We can download the PDF for M60, and there will be there should be also a PDF for M70. Yeah, there is a different separate for 70. I think this month they make some adjustment, and it was for the hemoglobin. The like here the range for hemoglobin was slightly adjusted, so this is the reason why we call it revised. And we already sent the information to the customers that we revised the lot and we make some small adjustments. So this is the website. Reagents, analyzers, all those things. Here you can find the information. And as you can see, Cormay is also producing some other reagents for Horiba, Sysmex, and Mindray analyzer. And this is also a mythic line, but mythic line, the reagents are not the same as an Orphy reagent, although they are produced in the same factory, but this is actually a different set of reagents, this mythic line. Yeah, as you can see, different catalog number, different reagent, and this is only for mythic 18, and there is also a control material for this set of reagents. So this is something which is common like in the Polish market, I believe. What else you can find? You can also find the veterinary products. Clinical chemistry is quite big because you know the Cormay itself is a clinical chemistry company. So as you can see here is the list of the available reagents. Oh, this is the same thing, clinical chemistry analyzers. Let's see what else we have here. Related products, and here we have, for example, the reagent set which are available for Accent MC 300. Sorry, M320, not MC. Calibrators, control washing solution, consumables, IC accessories. So everything should be here. So even if you are not logged in, you can have access to some parts of the website. But in order to gain the access to service documents, for example, you will need to log in. So let's log in with my credentials. I'm not a robot. Some kind of CAPTCHA is here. And go to service support. Go to part catalog. This is one thing. Right now we only have part catalog for the hematology, but later we will make it also for biochemistry and different types of analyzers. And as you can see, this is a part catalog with the pictures. So we have an index, we have information for each analyzer, the part is suitable, and here you have the pictures of those parts. Maybe not everywhere we have a picture, but we try to do our best. Oh, right, like you can see one picture is missing, so we need to update that. But we try to do our best to make this part catalog as best as possible with the resources that we have, the time that we have. As you can see, there is a lot of pictures, a lot of parts only for Mythic 60, or some of those parts will also work with the other analyzers. So it's a part catalog. This is very useful because sometimes you don't know uh, what is the name of the part, and simply you just need to find it, so you can find it according to the picture. Or another way is simply just send us an email with a picture of the part and just ask us for help. The training part, you already know that because this is the part that you use to sign in for this training. Installation protocol. This is the part of the website which will be redone or redo in the near future. So I believe next year. We are currently working on this topic. Next year, this will be done a little bit different. And every every new installation of the analyzer should be basically should go through the installation protocol, because this will be required in the agreements between our company and your company. So if this will not be filled by you during the installation, we can reject the warranty because there will be no installation report form, for example. Right. So this is very important to have all those things. There is also complaint form in this kind of form, and at this point, this complaint form is usually used to send send a complaint about the reagent or some kind of problem with the results. And this is directed to the QC department at this point. But we also working on this topic. So actually, somewhere in the next year, uh, the communication with us will be done by the website, right? We will try to switch from the email approach to the website approach, and simply there will be a form which will allows you to put all necessary information, and this will be also something which can guide you through your problem, and maybe it will even suggest you some kind of solutions at the end of this thing. And of course, later we will receive your complaint or we will receive your question from this website, and we can answer by the email. But the first step of communication will be by the website. Documents. So here is a document section, and some of those things, basically most of those things, are available for the uh, login users. But MSDSS, IFUs, DOC, ASCII sheets, those are available for everyone. But user manual, carryover, application import files, application guides, I think those are available for login users. So service support, this is actually the area where you can download the software updates, where you can download the service manual. As you can see, software updates, technical notes, some additional technical notes, spare part catalog is also here, and service manual can be downloaded from here. The same thing can be done for the M70 software. Do we have the software update? Yeah, there is a software update. Technical notes, there is not many of those, but we have some. For other analyzer, the same story, right? Software updates, some kind of documents, technical notes, and service manuals can be downloaded from here. For clinical chemistry, the same thing. Software, service manual, technical notes, if we have something like technical notes. Urine analysis, the same thing. Software, all those things. Veterinary products is not that big, but we have some stuff for mitigating vet and all those. Right. So this is it. By the way, If you still don't have access to the website, what you need to do is go to I think it was somewhere here. Or it's not here. Yeah, international service, international department. So this is the contact to the sales manager at the international sales department. So this is the email which you can use to gain the access to the website. Or if you know who is your sales manager, you can also contact your sales manager directly. This is also possible in this case. By the way, please notice that when I log in, there is an additional button located like here. So by pressing here, I gain the access to a generator which allows me to generate a service password, temporary password for Mythic 70. And in the future, the Mythic 60 software will be updated in the same way. So in order to have a service technician password, you will need to use this website also. You will need to use this website for password generation every day. We were actually uh, forced, or maybe not forced, but new regulation in the European Union, which is EVDR, requires from us to be more strict with the cybersecurity, and this is the reason why we need to introduce like this way of accessing the analyzer by use of technician. And as you can see, in order to generate this password, you need to type the correct serial number of the analyzer, choose a date for which you want to generate the password, and choose a type of the password. One will be administrator, one will be service, and I will try to explain you the differences between the administrator and the service passwords later when we will have Mythic 70 here. So this is it. And this is the password. This is the new thing. Um, what else you can find? The LinkedIn account. So usually the company is sharing a lot of information uh, about the events which happens in the company, and is sharing some stuff that is done in the trade fairs or something like that. Sometimes we also announce some things like when we're launching new products or we are updating something. So this is also done by the LinkedIn. Of course, you will usually find the same or similar informations on the website, but those kind of informations are limited here on the website. So better to just observe us over the LinkedIn. I think this is the best approach. Okay, let me just find another presentation. Okay, during this presentation, we will overview the graphic user interface, and also we will overview some stuff related to the application. So by application, I have in mind the way how Analyzer is presenting the results, how Analyzer is flagging the results. So I'll try to explain that during this presentation. But first, maybe we will make like a short 10 minutes break, and then we will carry on with the rest of this presentation. Okay, thank you for your patience. And what do you think about the quiz? We will try to introduce some kind of stuff like that because we want to have participants be more focused during the training. Basically, this is what you will see during this training like a few times. And I will try to make those questions as I go. And as you can see, only the first correct answer will win. And congrats to Yuri. You have 4 extra points for your tests. So the test is on the last day. So you will already have like a 4 extra points for your tests. And as I said, right now we will continue with the service training presentation. This is the overview of the software, of the graphic user interface, and there is also a few slides about the application, flags, and all those things. So let's proceed. Few basic information about the analyzer can be found here. So in terms of working temperature, analyzer can work between 18 to 30 degrees. By the way, I still receiving the answers for the quiz, but this quiz number 1 is already closed. So you will have your chance on the next quiz. The working temperature of the analyzer, actually if the temperature in the laboratory is lower or higher than this temperature, analyzer should not sit in this lab because there is a big chance that this thing is not only the working temperature is not only related to the electronic part, it's also related to the reagent itself. So in this case, the reagents also require some stable temperature 24/7 during the storage and also during the transportation and also during the usage of the analyzer. This is very important to have correct results and all those things to have correct and stable results. This is what I want to say. Relative humidity, as you can see, there is some kind of range for this relative humidity. Maximum 80% at 32 degrees. Storage temperature can be between -10 and +50 degrees, but this is storage temperature for the analyzer itself. This is not for reagent. If you will, those temperatures, your reagents will not work, so they will be damaged. So keep this in mind, that they will be damaged. And altitude, the elevation above the sea level on which the analyzer can be used is up to 3,000 meters. So within with this elevation, up to this elevation, analyzer can still be used without any problems. Although you need to remember that if you are above 1,500 meters, you will need to activate the altitude option on the analyzer. So this need to be activated because the altitude option produces more vacuum for the impedance channel measurement. In terms of dimensions and weight of the analyzer, here we have it. It's around 13 kilograms, and in terms of size, it's a little bit bigger than 22 OT, but it's not that big, not that heavy. Power supply. The power supply is external, and actually this is the same power supply as we using in MITIC 22 OT, MITIC 22 AL. 60 uses it, and also 22. Sorry, MITIC 70 will use the same power supply. So this is one common part for 5D analyzer. Touch panel and LCD is 8.4 inch, and actually this is the same screen assembly as you know from 22 AL. In terms of connections. We have 5 USB ports. One is on the front of the analyzer and 4 are on the back, and they are multi-purpose. So for each of these ports you can connect external keyboard, you can connect the printer, you can connect the USB drive, you can connect the barcode reader, uh, and, uh, and that's it. This is basically what you can connect by those USB ports. Um, there is an Ethernet connection for LIS and serial RS232 for LIS, and power supply on the back. In terms of accessories, as you can see, we have few accessories, and I already mentioned about those things. So those things are listed here. Okay, we have another problem with the quality of the video. So what we can do, I already showed that. You can go to the what you can do is simply just you can simply just refresh your web page. This is another possibility. If something goes wrong, you can refresh the web page and just take a look here, check if the quality of your video is set to the maximum resolution. So this is something what you can try to do. Okay, let's wait so everyone will have a chance to refresh the web page. Okay, let's carry on. I hope everything is fine with the connection on all computers, cell phones, wherever you are using to watch this. Uh, external printers which we can connect to the analyzer. There is already uh, pre-installed the big database for the printers. So in this database we can find a lot of pre-installed drivers. and usually analyzer will be able to install those printers that you can find on your market, but it's not always the case. So our recommendation is to use the PCL3 or PCL6 compatible printers on the M60. There is the best chance to work with those printers. With the analyzer, since this analyzer is closed reagent system, there is no option for have it open reagent. We already include the USB barcode reader with the device. Sampling modes, we have whole blood mode. So in this case, sampling volume is 15.6 microliters, and for the pre-diluted mode, you will need to use 20 microliters of blood, and this blood need to be pre-diluted in the diluent, and analyzer can dose the diluent into some external tube, into Eppendorf or sample tube. Throughput is 60 samples per hour, in theory, at least according to the time of the one cycle. But in practice, if the user is doing some other stuff, there is no way to have like this throughput for this analyzer, because this is limited by the user, right? This is not an autoloader machine. This is the open tube machine. So in this case, the user will limit the throughput of the analyzer. It's roughly 60 samples per hour, let's say, according to the cycle time. We can have 60 samples per hour, but it's not possible with the user input. Storage up to 35,000 parameters can be stored on the analyzer. Parameters list. So what we are seeing here is a complete white blood cells count, or total white blood cells count. This is actually from impedance channel. And later from optical channel, we have lymphocytes count and percentage monocytes count and percentage neutrophils count, eosinophils, basophils count and percentage, all those things. And we have two additional research-only parameters. So those will be atypical lymphocytes, immature white blood cells, immature cells, right? So they can be also reported as a as a count number or percentage. For RBC parameters, there is nothing special. Actually, the analyzer has the same set of parameters here as the previous our products. So the device can record the total red blood cells count, hemoglobin concentration, hematocrit, mean cell volume, red blood cells distribution width, red blood cells distribution width. One is a CV, one is a SD, so they are measured in a different position on the histogram, and those are two different parameters. Mean cell hemoglobin, mean cell hemoglobin concentration. For the PLT parameters, we have complete or total platelet count, mean platelet volume MPV, platelet crit PCT, platelet distribution width, platelet large cell cell ratio PLCR, and also with the future software updates, we will introduce a new parameter to the platelet parameters, and this will be PLCC, which is already present in the M70, but is not present here. But as I said, with the okay. In the meantime, I'm seeing that potentially I can have some kind of problem with the connection. So I don't know what is wrong, but as I said previously over the WhatsApp chat, just refresh the website, web browser, or just close and open the link if you are watching this on the mobile device, because from time to time I'm seeing that the streaming software is losing connection for a short period of time, but is reconnecting itself. So at this time, you can also have some kind of problem with the feeds. connecting and disconnecting. So what I can do, I don't know if I can do that right now. Okay, I will stop the stream for a second and I will try to change some settings so maybe the connection will be a little bit better. So just give me a second and just refresh the website. Okay, let's carry on. I hope right now the connection will be more stable and we will not lose any data. Okay. Reagent specification. So what are the functions of each specific reagent? So lyse, in this case, we are using the only one reagent. This is the name, only one, because it has a few functions. So it's used for WBC and hemoglobin measurements to lyse the red blood cells. So it's destroying red blood cells and allows us to basically measure the total number of white blood cells and also measure the hemoglobin concentration in the same solution. Enable cells subpopulation differentiation. So this is the 5-diff part of its function. So actually this allows us to basically use the same reagent for optical analysis in the optical bench, and enables the WBC counting in the same thing, in the same way in the impedance channel, and it will stabilize the hemoglobin. So this is the function related to the hemoglobin, stabilize and actually allows us to measure the concentration of the hemoglobin. So diluent function used for all dilutions. So it's used in the WBC chamber, in the RBC PLT chamber, and to make all those dilutions for all those processes. It's also used for instrument rinsing and is used as a sheeting liquid in the optical bench, right? So this is also part of the optical system, the diluent itself. And the cleaner is a third reagent, so it's used during the shutdown and in order to backflash aperture during each cycle. So this is one of the functions of the cleaner in this case. So as the name suggests, the cleaner is used for cleaning, right? So the name can suggest also the function of the diluent and the function of the lyse in this. Although lyse also have one more function which is not specified here, but the lyse also have one very specific function, and actually the pressure which is produced by the lyse piston and the lyse reagent is used to push a sample through the flow cell. And later, when we will analyze the fluidic diagram, I will try to explain this to you. Open close shelf life. So what is closed shelf life? It's actually usually those reagents are produced and shipped to the customer with a shelf life up to 2 years, right, until the expiration date. But when you will open the reagent and it's sitting on board of the analyzer, this tank is only meant to be used for 60 days because during the operation of the analyzer, we are constantly introduce some kind of contamination from the outside. It can be dust, it can be uh, also some kind of contaminated air with some small particles and many things, and this can contaminate your reagent. So this is the reason why analyzer will only allows you to use the complete set of reagent for 60 days only. And actually, if you think that those 60 days will not be enough to consume those reagents, if your customer is making more than 10 samples per day and it's working for 5 days per week, for sure they will consume the whole volume of the reagent within those 60 days. There is no risk of losing. But if you have a customer which is making less than 10 samples per day, I think this is not good for your business. And actually, um, the number of some you will not have a money from this customer because they are not making enough profit in reagents uh, to make this feasible. And we can make an even calculation, show you that. So here I have a calculator. So let's say 10 samples, sorry, 10 samples per day times 5 days times 4 weeks, right? 4 weeks in month times times 2. How many? 400 samples. And actually, later when we will go to the reagent menu on the analyzer, I don't know if I have reagents which can be used here, but what I want to say is when you will upload the information about the reagents to the analyzer, usually analyzer will show you something around 450, 460 samples from this complete set of reagents. So actually this is 400 and 450, 60 is a very close number. And what is shown by the analyzer on the screen is actually just a theoretical number. It's not a real number because this number which is shown on the screen should be uh, reduced by the number of shutdown, startups, calibration, and all those things. So the real number will be usually a little bit lower than the number which is shown by the analyzer. And what I have in mind right now is show you. Let me just show you this real quick. Uh, maybe like that. So this is the analyzer, and here we have those numbers. And as you can see, some reagents they are already consumed, and let's say lies. It's only 25% left in the analyzer, and as you can see, autonomy diff from this amount of reagent is around 113. So actually, if we will have complete set of reagents installed on the analyzer, I believe this autonomy run will be something around 450 samples. Right. So this is that number which I have in mind. Okay, let's go back to the presentation. Here is the reagent consumption table for the software version above 1.00. So I think right now, currently, there was no updates to this consumption table, so still this thing is valid. And if you will compare the mm, if you will compare the consumption of reagent for the standard CBC and diff analysis, you will see that those numbers are lower than numbers for MITIC 22 OT. Right, this is what this was our goal to have this consumption lower. Background limits. So during the startup of the analyzer, device will perform a background check, and this process should need to is assuring you that the analyzer is performing well. And the whole point of this process is simply just to uh, prepare the analyzer for the analysis and make sure that there is no excessive background level from the reagent or potentially from any kind of contamination in the fluidic system of the analyzer. So this is the reason why we have the limits, right? So analyzer, basically, if you will exceed the limit during the startup, device will not allow you to make any analysis because you will exceed the limit for a given parameter. So you may ask, what is the diff parameter here? And actually, diff is a number of particle registered by the optical bench. Right? This is the number of particles registered by the optical bench. Right? So keep this in mind. This is something which can confuse you on the beginning. Next slide. Precision of the analyzer in the repeatability mode. So how those numbers were obtained? So what we need to have is we need to take non-pathological blood where the number of each population or the results for those analyses are above those numbers here. As you can see, WBC should they should be lower than this range. If they are not lower, it means that your blood is not fresh, for example, or maybe there is something wrong with your analyzer. So actually, this repeatability test for each for which there is a dedicated menu, it's very useful, and it can be used for to make to make to check if analyzer is working fine or not. So it's like that. Linearity limit for each parameter. Uh, so we have like a two things here. One is the linearity limit of the analyzer in given range. So so for WBC, the linearity is between 0.2 to 100, and in this range we have 0.4 or plus and minus 4% linearity limit. Or above this 100 limit, we are talking about the reportable range of the analyzer. So it's between 100 and 150 analyzers can still count some cells, but in this case, the results of this analysis is not that accurate. So actually, analyzer will also report you that it's above the result is above the linearity range, because if we are above 100, analyzer next to the results will put a plus sign, and actually the diff parameters will not be present during this measurement. So what you can do in this case, you can simply just make a pre-dilution and run your analysis within the pre-dilution mode, and this should give you the correct results because the pre-dilution ratio is around 1 to 15. So in this case, analyzer can report even very, very, very big results. RBC, the same thing. There is a linearity limit and also reportable limit. For the hemoglobin, we only have like a one limit, so linearity here is very, very big. It's basically not possible to have such a high elevated results with a human sample, but it's possible to measure this thing by the analyzer. For hematocrit, same story. It's not possible to have like a those kind of low number of red blood cells in the stream, and also everything above the 70% basically not visible. But here is the linearity limit for this parameter. MCV, the same thing. This is the range within analyzer can measure the red blood cells, the mean corpuscular volume of the red blood cells, and for the PLTs, the linearity limit is between 10,000 cells and 200,000 cells. So basically, it's 2 million red blood cells per microliter of blood, which is very, very high in this case, right? So here we are talking about a very big pathology. Dynamic clustering. So what is the dynamic clustering? It's a basically a dynamic classification of the leukocytes of the white blood cell. So the algorithm itself automatically defines the cell subpopulation area at each run. So the algorithm uses some successive statistical analysis to compare the coordinates of the element and define the population threshold. So what does it mean? Take a look here. Those eosinophilous populations are cut in half by the static threshold. So actually the dynamic threshold is allowing us, or maybe not allowing us, but is dynamically changing the position of, for example, this discriminator. So this discriminator will go through this area, and also between lymphocytes and monocytes, and maybe between noise area and the and the lymphocytes will also cut this or separate those population in the better way. And dynamic clustering is actually it's enabled in the run sample menu. It's also enabled in the quality control, and it's enabled in the repeatability mode. It's not applied in the calibration menu, because in the calibration menu we are not even relying on the scattergram. We only relying on the total number of white blood cells. And this is the example where the scattergram is already looking correct. On the previous one, you see that there was a problem, like here in this area, presumably between lympho and monocytes, we also don't have a correct separation, and presumably between noise area and lymphocytes, there was also an issue with the separation. And on this example, analyzer adjusts the position of the histogram in such a way, of scattergram in such a way that we already have the correct separation between each population of the cell. So as you can see, the lymphocytes, they are appearing in the correct position. The monocytes, they are appearing in the correct position. Neutrophiles and eosinophiles, they are appearing in the correct position. And also there is a small population of basophiles here in this region. Between those two slightly angled discriminators, we have basically atypical lymphocytes, and everything in this area of the scattergram, those are atypical lymphocytes, big immature white blood cells, right? So this is what we are seeing in this area. Dynamic clustering, right? So what is dynamic clustering? Okay, the algorithm has some limits. So one of the limits is related to the number of particles which were registered in the optical system. If the number of elements or number of particles registered in the optical system is less than 1,000 particles, and when I'm saying 1,000, I'm not referring to 1000 white blood cells per microliter. This is just the number of particles without uh, any specific meaning. This is just 1000 particles registered by the optical system. So here is the example of that, and in this case you can see that there is a very small amount of the cells registered. So in this case the dynamic clustering will not be applied, and analyzer will simply just give you the clustering error message underneath the results, and there will be also information that algorithm failure, or actually algorithm is not working. This is how we should explain this to the customer, that the algorithm is not working. And actually in this case analyzer will apply default thresholds, because there is a set of default thresholds, like those kind of things, that default thresholds will be applied. Or another possibility is less than 50% of the total elements are inside the population area. So this is the example of that. So you can see that there is a lot of cells register in some kind of noise 1 or noise 2 area, and those can be this is example of leukemia, or this can be example of, as you can see in the histogram here on the beginning, has a very big peak. So presumably what we can have here is the situation where the lyse material, lyse reagents was not able to completely lyse or destroy the red blood cells, and those red blood cells they can appear here. Or another possibility, that we are seeing some clogs from the PLTs, because lyse is also not destroying the PLTs. Or we have a situation where there is a presence of very small lymphocytes in the bloodstream, but actually I will have some doubts about the lymphocytes, because we have some population of the lymphocytes here, and what we are seeing here, this big blob here, it's I believe it's some kind of leukemia. So those cells which are registered here, those cells should not be classified by any types of normal cells. So in this case, analyzer will also for sure show you some kind of error messages, and one of these messages will be review diff. So under the microscope, you will need to check the analyzer and see what kind of cells were seen by the analyzer in this case. So in this case, we also have clustering error, and as I said, in this case, when the dynamic clustering is not active, analyzer will apply the default thresholds, and it will also give you some kind of information about each population of the cells. But you can clearly see that this is not looking like a standard scattergram. This is how the standard scattergram should look like. This exact thing, it's I believe it's some kind of leukemia example, and those cells which are here in this population, this is basically some white blood cells which should not be classified as a 5 population of the cells. Those are so small white blood cells, maybe small neutrophils or different kind of cells. I don't know how. It's hard. It's not easy to describe from the scattergram. What we know about this about those cells has a size which is similar to lymphocytes, and in terms of optical parameters, for sure they have a optical appearance or absorbance similar to neutrophils. So we are talking about granules and lobules inside, and in terms of size, we are talking about the very small cells, because they are also appearing in the histogram as a small cells. So everything on this side, this is the vertical axis, sorry, the horizontal axis is a size, and the vertical axis is actually the optical parameter, which we call axial light loss. So it's the amount of light which was lost during the transition of the light through the cell. So this is what we know about the cell. Dynamic clustering in the QC mode. If you are making some kind of research, over the stability of the QC material over time, you can try to enable the QC, I mean the fixed thresholds for the QC material. So what does it mean? It means that the dynamic clustering can be disabled for the QC analysis, right? This is possible, but it's only possible for the QC analysis, for the QC measurement. And in this case, analyzer will apply to the default thresholds, and then you can basically make some research over the stability of the QC material, and you can observe how QC material behaves over time. And please remember that the time uh, when the QC material is stable after the opening, right? For mid 5D, it's only 15 days, right? 15 days or roughly 2 weeks, right? So this will be a correct answer here. 15 days, 2 weeks for the QC. Having this in mind, the dynamic clustering, since the dynamic clustering can adjust for the different look of the scattergram, and also we have some new features in the flow cell. This is the new injector size in the flow cell. Previously, the injector size in the flow cell was only 80 micrometers. Now we have 200 micrometers in diameter. So it means that the analyzer itself will work better even with some older blood. I mean, by older, the device itself can correctly differentiate white blood cells even after 12 or even 24 hours when the cells are more fragile. But for this, you need to make sure that the material was kept in fridge. And it has this approach has some advantages, because sometimes you are not able to test your blood immediately, especially in some rural areas, and the blood need to be transferred for a few hours to some kind of laboratories in order to be tested. With the M60, this is basically possible to make these tests after a few hours when the blood was collected. But keep in mind, the blood should be stored in the fridge during this time, and by any means, this is not recommended by any standards at this point. The standards are saying that the blood should be processed or tested within 4 to 6 hours after the blood was collected, and later, when we are waiting for longer, the blood can already start to deteriorate, and actually this can give us wrong results. But Mythic 60 has dynamic scattering, so dynamic scattering can also help you with such a older samples. And from our research that we done here in our lab, we know that even 12 or even 24 hours after the blood was collected and keep it in the fridge, we still have very similar results, uh, respective in respect to the same sample analysis, day before, 12 to 24 hours before. So this was done on our side. So we check this. Okay, I have a message that the quality is not good. So let me check that on my side. Mm, I see excellent connection. And also the streaming software is sending data. So what is happening, as I mentioned by the chat, most likely in this case you need to change the settings of the YouTube player to have a higher resolution. So what is happening, usually the YouTube is trying to adjust for your internet quality. So this is the reason why you are losing the quality in this case. So maybe you just need to find a better internet on your side, and then the stream can be done on the full resolution that we provide you. Okay, the next part of this presentation will be about the graphic user interface. But before we will proceed, let's make another short, like a 10 minutes break. Because right now I need to set up the camera, so you will have a better view of the analyzer. So you just need to give me a moment for that. And I will also try to send you another quiz. So stay tuned. Within 2-3 minutes, I will send you a new quiz question. So as a last time, the first who will answer correctly to all of those questions will have some extra point for a test. Okay, as you can see, I'm back, and right now we have an analyzer with us, so we will work with the device. So this is the front panel of the analyzer, as you can see, and actually we are in the reagent menu. So this is what usually you will see after you will log in into the analyzer. So maybe we can log out first and then log into the device. So let's zoom in so you can see it a little bit better here. So if you read the service manual, you know what is the uh, instruction. Sorry, what is the password for the analyzer? So what you need to have right now, if you want to log in as a service technician, you need to type the password GT9XB12. Later, when you want to log in as a technician, when we will update the software, we will need to have approach here the same as approach from the Mythic 70, where you need to generate the password from the website. Okay, we log in. So let's overview uh, the software itself. So right now I will try to show you the meaning, the functions of all those things. So stay tuned and let's take a look what we have on the main screen. We have a few buttons on the top, like a previous tools menu, about, and also underneath the this button we also have a function. I mean, underneath the time and date we also have a function. So just keep this in mind. Yeah, sorry, right now I was answering the question. I'm not sure what you have in mind. So, oh, about the password. Yeah, the password, actually it's in the service manual. So when I was sharing the documents with you, uh, when I was inviting you for this service training, actually I also share a link to the folder where you can find where all those things can be found. One way to access them is by use of website, our website, formaydiagnostics.com. But also, let me just share it, the screen with you. But also this website. This is actually a folder which we share with you, and if you will go here to manual collection, you will find the service manual for all Mythic analyzers. Right. So this can be the password can be found here, or another possibility is download the service manual is to go to for my diagnostics. You need to log in first. Service documents, service support, hematology, or maybe here, service manual. Right, can be downloaded here, or if you will go to hematology analyzer Mythic 60 and you are logged in, you can also download user and service manual directly from here. You don't need to go to service support and documents. So this is the way. And the password is GT9XB12, and you will find the information about the password in the manual. So just read the manual. I see that you didn't read it. So Don't worry, there will be time to do that. Also, please read the manual. This is very big source of knowledge about the instrument. So you need to read the service manual. Okay, we are in the menu. We are in the menu, so we have a few functions on the top. There is a previous tools menu, all those things. So what are those things? If we will go to Stat menu, for example, QC, and we want to go one level backwards, we just press on previous. As you can see, it's going back and back. If we will go to Stat QC, and we want to go to main menu, to this home screen, we press on menu and it's going back to the home screen. If we are in Stat QC and we will press on tools, additional window will appear with some extra functions which are only available for this particular menu, right? As you can see, it's not available here. For main menu here, we also, maybe I will use my finger. There is also no tools available. See, no tools available. Startup shutdown. So startup, it's actually a process which is running the rinsing process in the analyzer, and also during this process we are running the background check for the analyzer. So this is the thing that need to be done every day at the beginning of the day. When the user is operating the analyzer, they need to run a startup. And also every day they need to run a shutdown. An analyzer need to be in the shutdown state for at least 4 hours. Right, please remember that. Shutdown and startup. Shutdown is basically preparing the analyzer for maybe not prepared, but it's cleaning the analyzer after the day of the operation. So this is important to run this thing. Okay, the next menu which we have here is a stat, and in this menu we have a way to run the QC, calibration and repeatability tests. So if we will go to QC, from this menu we can basically, if you have new analyzer, this menu will be completely empty. Right now on this analyzer I was running many analyses, as you can see, and some of this is basically not working here with this touch panel. So we grab maybe different pen. Maybe this will work better. Yeah, this one is working better. So by the way, what you want to use on the touch panel, you can use your finger, you can use some plastic things, but you don't want to use this end, right? You don't want to use a metal sharp object because this will damage the plastic on the touch panel, and this will basically require from you to replace it with a new one, right? But the plastic like that, it's working. Okay, there is something wrong with the panel. So what we can do, we can try to calibrate it. So let's log out. And when you are in the login window, I'm pressing the aspiration button 3 times, and now analyzer wants me to press in this position. Okay, press NK or wait. Press NK. Okay, let's abort this thing because I think I make a mistake. So let me show you that. It will be easier. Look, I'm pressing this window. Sorry, this button, aspiration. 1, 2, 3. And now the calibration menu appears. So what you need to do is simply just touch here, touch here, touch here, and touch here. So now the touch panel is calibrated. So let's log in GT9XB12. See, maybe this was the issue because I was completely installing the new software on this analyzer a few days ago. So maybe I didn't calibrate the touch panel in the correct way. So maybe this is the reason for having this strange issue. Okay, you see, yeah, now it's way better because I was noticing that before I was trying to press like here, and analyzer was pressing somewhere in this area, not here, but here, you know, and most likely there was small change, small shift uh, in the, yeah, now it's much better. This is what you want to see. Now it's working. Okay, so this was some kind of look. Later we will come back to this menu because this is the menu for QC analysis and all those things. So we will try to set up the information here. We will try to run it. But, of course, this will be done today, but a little bit later because in the next within like a 1 hour we will switch to the installation of the analyzer. So during this thing I will show you that. QC calibration, this is the menu for the calibration, and as I said, we will use this menu a little bit later today. Repeatability, no, I don't want to delete them. So this is the menu which allows us to perform the repeatability test. So in this menu we can simply just perform series of repeats for one sample, and actually analyzer can calculate the mean value, SD and CV for us. And this is useful when you are troubleshooting the analyzer and you think that you fix it, and you can use this menu to make like a 20 repeats on one sample, and according to the results of your test, of your analysis, you can decide that if your analyzer is fixed or it's require a little bit more work, or you know, some parts need to be replaced. So the menu itself is quite useful in those terms. Okay, let's go back. Okay, stats, run sample. So this is the menu which allows us to run the sample analysis. So what we are seeing here, usually when you will perform the startup, uh, at the beginning you will see the background levels on the analyzer, and as you can see, the background levels here, like, it's very low. It's basically zero. Some kind of particles will register in the PLT, RBC, and most likely in the WBC channel here. But since the the histograms here, they have an auto scaling. So even any small amount of noise here, which was picked by the analyzer, it will also be drawn as a big mountain. Big peak, but actually this is not what analyzer was saying. This is just some kind of noise particles in this region. So just keep this in mind that during the startup, during the background check, you can see some kind of small spikes, and this is quite normal. What is interesting here is basically those levels of the background for the background analysis. Right, and on the scattergram device, only, let's say, register few particles, let's say like a 2, and I can see some of those particles like in this region, right? But most of those particles, they are appearing like in the noise 1, noise 2 region, and there is only one particle here and one particle here. It's not visible on the screen, you need to trust me on that. Two particles which are appearing in the neutrophile, and this is actually the number of counts here, those two particles. And I'm not seeing anything else. Sorry, there is some kind of dust on the screen, so I'm trying to figure out where we have other particles, but maybe you can see it like here there are some particles and there is a one big one gray particle here and one gray particle. So this is actually what the analyzer was seeing. And it corresponds to this thing, because this is the diff number. This is the number of particles which were registered in the optical system during the measurement. This was one of the questions from the quiz. What else we can see here? Maybe I will just run one more sample, so more things will appear on the screen. So we will need to wait for that. But let's say that we want to set up a new sample analysis. So what we can do, we can press on next sample. And next sample is actually a menu which allows us to set up information about the sample in this case, right? So we can put the name of the patients from the keyboard. And we can put some kind of patient ID into this field, or use, we can also use the barcode reader, which I don't have, unfortunately, right now with me. Yeah, I think so. I don't bring it. I didn't bring it. So for the barcode reader, we need to wait just a second, but uh, but the barcode reader can be useful because we can basically scan the, we can scan the barcode from the sample tube, and the data will automatically fill one of these fields. And later, when we are working with the LIS system, the results can be reassigned in the LIS system. You don't need to type any type of information about the patient. Or if the analyzer itself is a standalone unit, of course, the only option will be to put all those data here, and you will have them on the printouts. This is also possible. What else we are seeing? The mode. So this is the mode of the operation. So there is a diff whole blood, diff pre-diluted, CBC whole blood, CBC pre-diluted. So I think that this is pretty straightforward, right? In terms of group, we have few predefined groups, and also there is a few more groups which can be predefined by the user. In total, there is a 12 extra groups which can be done, and we can choose the gender. Unspecified, male, female, right? Male. And type, yes. And save changes, yes. And as you can see, the next sample, which will be processed, it's a match. So it's actually something that we set up in the next sample menu. For example, if we will change the mode into diff pre-diluted, there is another button here which allows you to make a quick change of the mode. The analyzer is saying that next run will be done in the diff pre-diluted mode, and what you need to have is 20 microliters of whole blood, and this should be in 300 microliters of diluent, right? This should be pre-diluted in the diluent externally to the needle and run cycle. But take a look here. Another button appears. So this is diluent dispense button, and you are about to run diluent dispense cycle. Do you want to continue? Yes. And this is just a preparation for the diluent dispensing. Right now, please, analyzer is saying, please presence the tube, empty tube, and the instrument is going to deliver 300 microliters of the diluent through the needle. Press OK to continue. Well, I don't have a tube with me, or maybe I have. Just a second, I will just check that if I have any kind of Eppendorf or empty sample tube, so I can show you that. Or any kind of container. No. Okay, I don't have it, but later, if you like, we can show you the pre-diluted mode. So what I will do, switch the mode, and I will take some clot, because analyzer will dispense some diluent. I don't want to have this diluent on my analyzer, so just put a clot. And right now, analyzer simply just dispense this 300 microliters of diluent into, well, in this case it was a piece of tissue, but if you will put, you know, the empty sample tube here, it will dispense it into the sample tube. So this is the diluent dispense option, and later with this dispensed diluent, you will need to make your pre-dilution manually, externally, right? Analyzer will not do this for you. You will need to do this externally. And okay, let's change the mode to a normal one, and still we are like a matcha. So so what we are seeing on the screen is basically the normal, all the parameters are here. We are seeing the scattergram, although the scattergram is empty because the number of white blood cells was 0 in this case. The histogram for WBC is also empty. Later, when we will run some QC material, we will see all those things will be filled with the data which were obtained by the analyzer. And as you can see, in this case, when there is a blank sample, analyzer is not even trying to show you any kind of particles which were registered by the analyzer. Simply just treat them as a noise, right? It's not showing you that, but for the background, analyzer is showing you some spikes here, and this is normal. This is the information about the sample which is currently displayed, and when we will run the next black sample, here analyzer will display my name, because this will be basically the results for this exact thing, this exact name. And as I told you, some menus, they have additional tools available. So there is an option to transfer data to the LIS system. There is an option to print the data on the external printer, and we can connect the printer here later, and we'll try to print something. And we can save the results as a CSV file into the USB drive, and we can also close this exact window. There is also an option to delete results, but it's not in the run sample menu. It's actually the archive menu, or result menu. This is the name of the menu. And what you are seeing on here is the English version of the software. But for some customers, we already have some translations to different languages. So in many countries, English, it's okay. But if you like, you can work on your own translation. I know that right now with us, we have some Ukrainian customers. So most likely, guys, you don't want to work with the Russian translation. Just let us know. We can prepare some special files for you, and we will provide you an instruction. And in this way, together, we can make a Ukrainian translation. There is no problem with that, I believe. So this is it. For other peoples, there is the same approach. If you need to have a translation to your specific language, this is of course possible. Just let us know. We will share with you some special files and instruction, and the software which allows you to make a translation. And with this, with those things, you can make your translation. Of course, we will not make a translation for you. You will need to go through the software and just translate all the sentences, all the buttons, and everything what you are seeing on the screen to your language. But you know, it's possible. It's possible to do that. Okay, and as I said, Maciej, this was what we done previously. Okay, in my presentation, I have a few screens which are explaining a little bit more the flags which can potentially be displayed, like in those areas, and also information about the alerts, and all those things which will be displayed like in this area. So later, I'll try to show you that on my presentation. There is no need to do this here. Okay, the result menu. This is another menu which is available. And what we have here, let's take a look. Usually, the first thing which is displayed here is the runs from today, right? So analyzer is displaying all the runs which were done today, right? Today, or from yesterday if there was no runs from today, right? So this is what analyzer usually is displaying. So by pressing on details, we are seeing this detailed view of the results, right? This is quite simple. The same set of things. But if you will press here, we have something like few options. One additional option is to delete some results. So there is a trash bin icon. So by using that, you can delete. You are about to delete one result. So you want to continue? Yes. So I delete one result. So let's go to Tools and press all. So actually 2 of 232. So actually everything, sorry, everything which was, sorry, I just moved the camera just a little bit. Everything which is shown here is just the two results. So if you will type all, analyzer will try to delete every results which were on this exact screen. But if you will type the sequence, analyzer is removing just a few results. So you can type the sequence between 569, 570, and actually analyzer will delete those two. But since we only have two right now, and if we will type the all, analyzer will do the same exact thing. And other functions, send to LIS, print, USB save, and close this window. You already know the meaning of that. Date. In order to find some results, previous results from the analyzer's menu, you need to go to date. And what we need to have is just go and take a look on the structure, how everything looks like here. Here we have structure of the memory of the analyzer. Here we have year and month. So on this big lists, if you are using your analyzer for a few years, this list will be big because there will be 12 months in each year, you know, and all those things. So you will need to choose the correct year and month. Later, you need to choose a date in the given month and year, right? So we want to choose this one, 5, so it will be October 5th, a few days ago. And as you can see, there was some runs, some analysis done on this day. To be exact, it was 50 for analysis. So we can press on details, and this is some kind of background check. And this is something else. As you can see, there is a lot of there was a lot of analysis done on this one day with a few samples. I think I make some kind of tests. So as you can see, there is a lot of data, and some of them they are like at the same samples in the row. I think like I make 5 repeats or 4 repeats or something like that. So this is what we are seeing. We can also press on table view. Go back, and this is the table view for the given date, for the date that we choose. And as you can see, right, this is it. And we can also select some range. We can delete them. We can send them. We can print them. You know, all those things is available also from here. Okay, result date. This is that menu. That is nothing special. You just need to choose according to the year, month, and day in the month, and then you can find your result. There is no search query button, nothing like that. In the future, I believe we will make such an update because Mythic 70 already have a search button. So this is working quite fine, quite nice on the 70. So I think we want to have the same functionality on the Mythic 60. Reagent. So this is the menu which allows us to set up the reagent. So in order to set up, we need to have barcode reader. So just give me a second. I will try. Okay, and I'm back. I have a barcode reader, so we can do a few things with a barcode reader. Okay, analyzer is saying external barcode reader is connected, so this is like an opticon model. You may know this barcode from different our products. We are using opticons since the quality of those readers is quite good. They are not that expensive, and for normal operation with the analyzer, they are working quite fine. So what I want to do, let's go to the diluent and just take a look what will happen on the screen. Most likely, I don't know if I open this box of the diluent previously during my last presentation. I don't know, we should see. So I'm taking the barcode reader and I'm just scanning two barcodes which are located. I don't know if this is visible. Yeah, those two barcodes are located on the box. Let me just move it, right? And you simply just need to scan them, and this will allows us to upload the information. And as you can see, this reagent was already used by this analyzer because it was scanned in the past, so I'm not able to use the same set of reagent or the same box of reagent for the second time. Let's take a look if we will have any luck with the lice solution. Save changes. Yes, the lice solution was not used by the analyzer previously, so I can scan it. Reagent already used. So in this case, the cleaner itself was already scanned by the analyzer in the past, so I am not able to use it, exit without saving, and a reagent log. So somewhere here on this list, we already have information for this exact container with the diluent, and container with the cleaner should also be on this list. And as you can see, you can save this list or print this, but you are not able to delete this list. So what the reagent log is doing is allowing us only to use the original Orphe reagents and also only allowing us to use the reagent container once. It's not allowing us to use them a few times on the analyzer, right? So this is it. But lice and actually diluent and cleaner was already connected somewhere in the past to this analyzer. So this is the reason why analyzer is not allowing me to make second use of this container. But the lice bottle was most likely used on a different analyzer, or it's, you see, no, it was open before, but it was not used on this analyzer. So this is the reason why I was able to use it. And this is the procedure. You just need to go here, scan the barcodes, press save, and that's it. And the counter will change to 100. And for the cleaner, the same thing. And then the autonomy run will increase according to the volume of the reagents which are still in the analyzer's bottle. So please remember that it's very important to only connect, to always make this upload the information about the reagent in the correct way, because if you will do that in the way that you want to save some old reagent from the previous bottle and you will put some extra reagents, I mean, you will upload the information about the new reagent here, and you will not connect this bottle of reagent into the analyzer. You can have a situation that the consumption will already start to be counted by the analyzer, and from the next bottle you will have a common another error, and the amount of the reagent which will be left in the bottle will be bigger. It will be actually as twice as big as the previous one. And you don't want to mix any reagents in this analyzer. You don't want to fill the bottle with the previous with the leftovers from the previous one. You don't want to do that. And usually we program a dead volume in the software. There is a dead volume program, and actually this dead volume of the reagent bottles will not allow the analyzer to aspirate any kind of air bubbles, because analyzer will simply set that a reagent is depleted before any bubble aspiration will took place, right? This is the safety mechanism. Basically, we don't want to have this situation to happen. Okay, and since we are here and we basically upload, let's say that we upload all the information, we can press on prime each individual reagent, or we can prime all reagents, right? And this is the one of the procedures which need to be done during the commissioning, during the first startup installation of the analyzer. What else we are seeing here? The waste button. So the waste button allows us to basically set up the volume of the waste container which is used by the analyzer. So you can set up this thing to be like a 5-liter container, 10-liter container, 20-liter container, even a 100-liter container, if the end user will be able to lift the 100-liter container. Like this is a joke, you know. This is the joke with a 100-liter container. Usually the customer want to take like a 10-liter container, or sometimes even 20-liter containers. So it's really up to the customer how what is comfortable for them to carry, to basically uh, to manage, and all those things. So you need to talk with them, and according to the volume of your container, you can set this thing here. And when you will set it, and when the customer will basically replace the container with the new one, or just remove the waste from the analyzer, you just need to press on reset. So right now analyzer know that this is 10-liter container and it's completely empty, right? So this is the approach. Another possibility is to use the waste open drain option, and in this case analyzer is not controlling what is the volume of the waste container, right? What is the amount of the liquid inside, because it's analyzer is thinking that the waste that is going directly to the sewage, right? It's not controlling that. So there is that option also available for the analyzer. In many countries, this is not compliant with the is not comply with the regulation about the waste treatment. So you are not able to directly put the waste from the hematology from the biochemistry analyzer into the waste into the sewage system. So you will need to treat the waste in a way that it's appropriate for your country regulation. So sometimes you need to add some hypochlorite uh, into the waste container to potentially destroy any bio bio biohazard materials, because you know there will be some cells in this in the waste, right? And potentially some other things need to be destroyed before you will discard the waste material. Okay, let's keep it like a 10 liters. So basically this is it. This is a manual which allows us to set up and prime reagents. We also have a cycle counter. So this is basically the information how many cycles were run on this analyzer, and this analyzer only have 142 cycles, but I believe it was reset because we make a full software installation. So this is the reason why we have this thing reset. But this is also the device which is used by the service team for the presentation for the customers, and you know, this is not in the normal operation. Usually you will see the numbers will be in few thousands, few hundred thousands, according to the to the usage by the customer, because this is actually cycle counter. So it's actually the information about the number of measurements which were done on this analyzer, uh, number of startup, number of shutdowns, number of cleanings, flash cleaning, and fluidic control cycles which were done on the analyzer. On the other hand, the other side of the screen, we have the maintenance countdown. So actually, this countdown will show you the number of days for the next flash cleaning. So in this case, we already at 0. So most likely when we will turn on the analyzer tomorrow, the analyzer will show us the information that the flash cleaning need to be performed, right, during the operation of the analyzer. And flash cleaning, this is the um, this is that operation which need to be performed with the bleach solution, with the hypochlorite solution provided by Orphy flash cleaner. And short and big maintenance, those are the yearly maintenance and also 3 years maintenance. And later we will talk about those maintenance procedure and what need to be done during this maintenance procedure. Please notice that there is also a reset button, and this reset button is only active when you are login as a technician. This is not available for a normal user. I don't want to reset this thing, or maybe I will reset. Why not? And as you can see, it's a 0. So actually, if your customer is, let's say, and you want to collect the information how many samples the customer was running between maintenance to maintenance, you can always reset this counter during the maintenance, and you will have zeros when you will come to the analyzer for the next year maintenance. So this is it. Reagent log. So I already explained this to you. Logout. This is just a logout window. Sorry, logout function from the software. There is also about and this button. So actually, this about and the time and date button or icon will display same thing. So what we are seeing here, this is the name of the instrument. There is also the software version information, and important thing will be the serial number of the device. And if you are working with your analyzer in the LIS is configured as a network. By network, you can have the IP address, MAC address of the device display here, and also there is few more information about some kind of firmware, additional firmware information, and this is it. This is what you are seeing here. So let's go to service. So service is basically additional menu, which is available for technician. It's available for normal user, for also biologist. So maybe as a first thing, we will go to settings and user management and Sava. There is operator Sava, and let's change the password. 1, 2, 3, 4, 5, 6, 7. Oh, there is just a 6. 1, 2, 3, 4, 5, 6. So this will be biologist. Okay, we have 2 passwords. So let's log out. Let's was like that or V. I don't know. Let's try. Or maybe it was V. An error. Okay, let's try to type correct password. 1, 2, 3, 4, 5, 6. Login error. So I think it was V. 1, 2, 3, 4, 5, 6. No. Type Biolo. And the password for Biola was like that. Okay, settings, user manager, B, Saba, okay. Like that. 1, 2, 3, 4, 5, 6. Okay, now we are a normal user. We are logging as a operator, as you can see, Saba operator. So what we can do in the QC menu, sorry, in the stat menu, we are not able to perform calibration, but we can do QC and repeatability. We can upload the reagent information. This is doable, possible for us. In the run sample, we can run sample. So basically, this is the menu for normal or login level for the normal operator. If we will go to service settings, as you can see in the settings menu, we just have few options available for this user, but also there is no service menu available. Okay, let's log in as a biologist, which is the higher access level, a little bit higher. Biologist. So start menu, we can perform a calibration. We can run some results, we can delete results. All those things is possible. In service, we have a settings with a more options available, but still we don't have access to the service menu. And when we will log in to the GT9XB12, here we have technician menu, and actually this technician is only for technician. So you don't want to share the technician password with the end user, right? This is actually, this will give you some kind of problems if you will do that. Because when they have access to this menu, they can change some settings, they can change some gains, which should not be changed by the user. And in the settings, we also have those things available. Okay, so since we are discussing the options here, we will stay in this menu as a technician. So system init, this is just a software or fluidic system initialization. So if there will be emergency stopped or something like that, you can always okay, there are some questions. So uh, I will try to answer them. Yeah, the one question was about the format for the results which are exported. So those will be the CSV files. Event log, error log. So basically, this is just the information who logs in, what was done in terms of all the process which were done on the analyzer. On the other hand, this is the error log. So if we have any kind of errors display on the analyzer, or something happens, no diluent, right? Diluent was depleted or something like that, it will be displayed here. Backup and restore. When we are logging as a technician, we can come here and actually, by default, the data and setup is only available for biologists, but the CSV files, they are useful for technician, because from the CSV files you can have some additional information about the sample. Maybe it's not so useful for you, but when we, Orphe support, when we are discussing some issues with the customer, when we are troubleshooting the issues with the customer, it's very useful for us when we have the CSV files for the results. So you need to be logged in as a technician in order to make this backup from here. It will be very useful for us. Settings, those are the settings which are available also for biologists. So let's go to the first menu, lab parameters, lab preferences. So this is a basic menu which will set up the way how the things are displayed on the screen of the analyzer what kind of things will be displayed basically. So what is the diff format? So it can be percentage or absolute. So those are two options which are displaying the number of on the screen of the analyzer for diff parameter. So by default it's a percentage, but if you customer want to see the absolute number there, you can also set up in such a way that the absolute number will be displayed on the screen of the analyzer. But the printout give you an option. Well, the printout is printing both of those things, but actually on the screen of the analyzer there is not enough room to display everything at the same time, so you need to choose what will be shown on the screen. Auto incrementation of the sample ID. This is the option which allows you to well, analyzer will automatically increment the sample ID, but you can also put the sample ID for each sample by yourself. This is possible, and if I'm right, if we will go to run sample, I will take the barcode reader and I will scan the barcode from this pen. Yeah, next, as you can see, next sample ID. Analyzer is filling the sample ID with the barcode information, right? So this is actually the information from this barcode 590, 590, and 311. Yeah, so this is the thing that we are seeing, 311. Settings, lab parameters, lab preferences. So this is actually the option which allows you to also use the auto incrementation. If you are not using any barcode reader, you can rely on the auto incrementation option, and first sample will have a sample ID 1, second 2, 3, etc., and so on and so forth. It's like that. So QC alerts can be displayed or can be enabled or disabled, and RUO parameters can be enabled or disabled. What are the RUO parameters? So atypical lymphocytes, immature. We just switch the atypical lymphocyte, immature white blood cells, PCT, PDW, PLCR. Those are the RUO parameters. So when this option is not available, those parameters will not be displayed also on the screen. Units, so this is just a menu which allows you to change between different types of units, which will be displayed by the analyzer. CBC thresholds, so for this menu, basically I have also presentation, so later during this presentation I will try to show you that in the presentation. I think this will be a better way to display and to explain you the meaning of those things. Diff flags, so those are the flags for the diff parameters, and I will show you that on a different presentation. And reference ranges, this is the menu which allows you to set up, to change, to edit the reference ranges, which in fact should be added by each customer, by each laboratory according to the data that they have in the laboratory, because sometimes the laboratories are working with some specific population or subpopulation of customers, and they need to adjust those reference ranges accordingly. And here we have the calibration factors, and as you can see, there is a few of those calibration factors, and actually those 1, 2, 3, 4, 5, 6, those first 6 calibration factors will be set up by the mid-cal calibration, and other RDWCV, RDWSD, and PLCR will be set up, can be set up manually. And actually RDWSD This one is a little bit higher. It's 1.139, and actually this is set up by the software by us, so we change it to this level. We've been in here in lab parameters, right? Let's go back. Time and date. This is pretty much straightforward. This is allowing us to change the time and date. Automatic cycles. This need to have some small explains. So automatic power up settings. So you can actually set up, enable the analyzer to turn on from Monday to Friday, or from Sunday to Friday, or even if the Friday is day off on your side. You can set up the analyzer in such a way that it will turn on automatically at 6 a.m. every day, and it will run, let's say, startup in the background, and it will be almost ready to use after that. So this is that option. Auto cleaning frequency. This is the option which allows you to adjust the auto cleaning frequency. By default on this analyzer, we have it set to every 50 samples. So actually every 50 samples, analyzer will run the automatic cleaning procedure. It's not requiring any hypochlorite flash cleaner input by the user, but it's actually like a 3, maybe 4 minutes of some of the cleaning is required every 50 samples, so to ensure that the analysis will be performed well. And the automatic shutdown can be enabled or disabled, and actually when there is an idle time, there is no input from the user, analyzer will basically shut down itself, and by default this timer is set to 180 minutes, so it's roughly like 3 hours. Printer. In this menu we can install a printer. So just give me a second. I will connect the printer, since I have a printer here in this room. So maybe we can also okay. The printer is powering on. So let me just connect the USB drive to one of the ports on the back. So the cable will be okay. It seems that I also have a paper in the printer. The cable is connected. So let's go to the printer management. And right now, we're seeing that previously to this analyzer, there was a different printer connected, because it's saying local and not connected. So it means that it was installed already, but I want to install a new printer. So what I need to do is just press here and go through the setup. And if I'm right, this is a PCL6. I think so. This is a PCL6 printer. So in order to check that it's installed, we can print the test page. If this was the correct driver, choose. Yeah, let's see if this was the correct driver. Yeah, we have test page, and the analyzer is running Linux operating system. So as you can see, we have a printout. So it's a good thing. When you are setting up the printer here, you never want to set the printer as default, because I don't know why we have this option here, but actually if you will set the printer as default, it will work fine for 3-4 days, and after that you will need to install it one more time, because I don't know why we have this function here. It's not working usually correctly. Maybe it's for different types of printers. So we manage the printer, we install it like here, and now we need to go to printer settings, And from printer settings, usually it will, by default, it will be set like this, no printer. So you need to choose the printer that you install right now. And now we can basically specify what kind of options you want to print. So there are two headers line here on the top, so you can put information about the laboratory, some kind of cell phone number, all the things that you want. I think there is a room for like 50 signs or something like that. So a lot of information can be put there. And patient report option, we can enable or disable normal limit headers, comments, units, flags, and all pathologies, curves, all those things. And also we can choose which kind of results will be automatically prints. So startups, analysis results, and QC analysis. So I don't want to set up because analyzer will give you a printer error message if the printer is not connected or not active when we will run any analysis. So let's go to results. Let's choose some kind of results from the archive, and yeah, let's print them. Tools and print. Yes. Okay, and we have the results already. Okay, let me just switch the camera. So this is the printout. Sorry, I just messed the page just a little bit. All right, so this is the printout. It's looking a little bit different than what we are seeing on the screen, but as I said previously, in terms of diff parameters, look, we have lymphocytes percentage and lymphocytes numbers, right? So all those things are printed, but on the screen we only have a room to display one set of parameter, right? So we are not doing that. And one more thing, which is display only, is pathologist information. So those things which are displayed here on the back, printed on the bottom of the report, they are printed only. They are not displayed by the analyzer, right? And this is information about the potential pathologies which can be present here. So lymphopenia, neutrophilia, immature cells, presence, anisitosis, thrombocytopenia, giant platelets. So yeah, thrombocytopenia, giant platelets. Yes, this is possible because the histogram for the PLT it's showing us some presence of strange-looking cell in this area, and most likely some morphological alarms will be also triggered by those things. Yeah, according to the data, the PLT is very low, MPV is very high, and PCT it's very low. So most likely it's diagnosis or pathological information is correct. Okay, so we set up the printer, and let's go to settings. This is where we've been. Printer communication. This is the menu which allows us to set up the communication between the analyzer and LIS system. So those are the options: serial, Ethernet, and here we have additional setup things. So this is pretty much self-explanatory. I think this should work. If you have a the protocol description actually is in the service manual, so it's like a step-by-step instruction what to expect, what kind of data will be received by or sent by the analyzer to the LIS, and how the communication looks like, how to set up everything. So this should be sufficient to set up your communication in this way. user management. Here we can manage some users, so we can add new users, we can remove them, we can change the passwords for them. Software update, this is just a button which allows us to perform the software update on the analyzer. So if you have the software release on the USB drive, analyzer will find it and just say that no external storage device detected. So there is no USB drive connected, but what I can do, and I can take my USB drive where I think I have some kind of softwares and retrieve. And as you can see, the M60 want to make an update with the 050005, and actually this is software for M70. So this is a similar platform, but of course, during this update process, analyzer will figure out that, oh, this is wrong software, so it will fail. But if the correct software version for the Mythic 60 will be found on the USB drive, it will be displayed in the number. So just keep this in mind, that you need to have correct software release in the root folder of your USB drive. Next is troubleshooting. So in this menu, as you can see, we can troubleshoot a lot of problems. Um, so what we have here, there is something like fluidic control. So this is like a fluidic system or analyzer initialization. Flash cleaner, this is the bleaching procedure, flash cleaning. Drain bath, rinse bath. So this shit, just press it. This will basically drain the liquid from the chamber, and this will rinse the chamber. Okay. Uh, so drain the bath and rinse the baths. Backflash aperture, so this is backflashing the impedance channel aperture. Backflash the optical bench, this is cleaning the optical bench. Needle dismantling, this is useful when you are replacing the O-ring on the analyzer, so you can try to do this on your analyzer and just we'll see what will happen. The analyzer will put the needle in a more convenient way, so it's easier to basically remove rinsing head from the rocker mechanism. Check rocker. So this is just checking the movement of the rocker. Park motors. Clean the analyzer. This is auto cleaning procedure. Drain for backup. So this is actually for long-term storage. You can use this thing to safely prepare the analyzer for long-term storage. Syringe greasing. So syringes need to be greased even by the user every 6 months. So this is available for biologists, this menu, and for normal user, I believe. Drain flow cells. So this is removing the liquid from the flow cell if you want to basically replace the flow cell or do something with the flow cell maintenance. Check sensors valve. So this is additional menu, and here in this menu we can test a few things on the analyzer. We can test the functions of the valves, we can activate them or deactivate them. We can check the real-time reading from each sensor, like a temperature sensor, pressure sensors, and all those things. We can turn on the optical LED, as you can see, and the reading for ALL channel just rise, and we can also disable the hemoglobin LED, and as you can see, the reading for the impedance channel WBC chamber hemoglobin sensor also was changed because this is actually affecting this exact module. Set AC on, AC off. This is only the option which allows you to basically activate the current across the aperture in the impedance channel. So in this case, there is no reading here because for this measurement, you will need to take a multimeter and just make this measurement by yourself. Later, I will show you a video which is explaining this whole process. And test vacuum. The vacuum level here will change, and actually this option is allows you to see if the pressure sensor is correctly aligned and if the pressure or vacuum, in this case, I should say, vacuum is also stable and at the good level. So as we are talking here, and you see the pressure just settle to one specific level and is sitting on the same level. So it's mean that your analyzer has correct vacuum level and it's stable. If this pressure will not be stable, it means that there is a potentially some kind of leak in the system. So you need to troubleshoot what is wrong. If you were talking about the older analyzer, like a few years old, 5 years old, maybe it's a time. It's a time to replace the pistons and also the O-rings in the analyzer. We can also test a pump function. So for the pump test, analyzer is producing the vacuum by the pump. Right now, minus 380, 72, 72. Yeah, it's actually there is a different test, different approach to this test, but you see it was above or below minus 300, so it means that the vacuum produced by the pump is also at the good level. Check sensors. Check syringe. This is just a mechanical check to the syringe movement. So syringe will go up and down, and check needle is going up and down. Park motor is actually parking the motors in one specific position for them. Troubleshooting and technician. So technician menu, we will try to I will try to explain this technician menu a little bit later, maybe not today because we are already running out of time for today's presentation, for today's service training. So right now, let's make a short break. And during this break, I will also share some questions for the quiz. I think this will be the last quiz for today. And then we will carry on. And as I said, during the rest of my presentation, I will try to explain you the topics related to the application. So flags interpretations, error interpretations, all those things will be right now in the last part of our service training. Okay. So for the last quiz, I think I have answers from two peoples at the same time, and they were correct. So I decided to give points to those two peoples. And as you saw, the D, normal user, or yeah, the normal user is not able to make a calibration. He can run the analysis, he can run the QC, but he's not able to make a calibration. The biologist, second access level, can do the calibration, but not normal user. Okay, let's talk about the results or this menu, which allows us to make an analysis in some details. So everything which is display in this blue bracket or blue, it's highlighted with the blue. It's a RUO parameter. So as I said, when the RUO is not enabled, this will not be displayed on the screen of the analyzer. And flag area, it's actually here next to the result. So for each results, we can have many different flags, a few different flags actually. So later on the future slides, I will try to explain those to you. And also we have the alarms area. Those can be morphological alarms and also system alarms. Can be displayed in this box. And what else we have? We have a scattergram and we have a histogram. So actually, if you will press on the scattergram or histogram, another window will display with the bigger version of the same thing that you have here. Flag box. Well, it's not flag; it's the alarm box actually. Okay, and those things will be also discussed later on future slides. And by the way, as I said, pathological alarms related to the results will be printed only. They are not displayed here on the screen. They are printed only. Results flags. So here we have a few examples of the results. So I believe it will be easier for you to understand that. So those excess means that there is a numerical value underneath. So it's, for example, 1.8, WBC 1.8, but there is an asterisk sign. So it means that there was an inconsistent data between two measurements for the same sample. So in other words, device detect a clock for the WBC. This clock detection is working also for RBC. It's working also for PLT analysis. Analyzer will display asterisk signs also next to those parameters. When we have a situation, oh, by the way, another thing, when a device will detect the clock on the WBC, there will be, of course, the asterisk sign, but also analyzer will display the WCL alarm in the system alerts box, like in this area. For the RBC, if there will be asterisks, there will be error CL alarm. So it's a clock in the RBC channel, or for PLT, this will be also for RBC channel because this is using the same measurement channel or measurement chamber. Okay, let's carry on. So excess and plus at the end. So it's mean that there is a numerical value and there is a plus sign next to this parameter. The same thing for hematocrit, we have the plus sign. Why? Because maybe you remember that, but actually the RBC and hematocrit in this case is above the linearity limit for this parameter. As you can see, the linearity limit is up to 8.0 for RBC, and for hematocrit is up to 70%, right? So actually, in this case, the result is above the linearity limit. This is the reason why the result is displayed with a plus. And actually, if some parameters are related to the RBC, so for example, here, the thing which is related to the RBC will be some hemoglobin parameters, because the analyzers use the hemoglobin measurement and also the RBC parameters to calculate some of them. They will not be displayed by the analyzer. And if we will have a situation that WBC will be above 100 and there will be plus sign, the diff parameter will not be displayed by the analyzer, right? So it's like that. Plus, for 5 pluses. So instead of results, we only have plus. So this is the situation like that. So in this case, the reportable range for the white blood cells is actually up to 150,000 cells per microliter. So actually the result here for this WBC analysis was above 150,000 cells, right? So this is the reason, and we have a rejected. The result is rejected because we are above the linearity limit. So what we need to do is actually we need to make a pre-dilution and run this sample in the pre-diluted mode, right? So this most likely will fix the error because the dilution factor is 1 to 16. So actually in this case, there is a big chance that we can measure such a sample. And in this case, also related parameters like diff parameters will not be displayed by the analyzer. So XXXX and exclamation mark. It means that there is an alarm associated to this parameter. So we have like a monocytes and there is exclamation mark. Basophiles, exclamation mark. So actually morphological alarm. This is the reason for having this thing here. So noise 2 is not that, but neutrophil low is actually a region between neutrophiles and monocytes, and maybe you can see it or not, but in this region we have a lot of cells. So this is the reason why this alarm was raised. And also basophiles, as you can see, it's in the same region, so most likely this is the reason for having those exclamation mark in this section. And hematocrit, MCV, as you can see, all those things are elevated. MCHC, so this is the reason, and also R2 alarm is raised. So this is the reason why we have the exclamation mark like in this section, because this is related the way how the RBC histogram looks like. Numerical value plus some kind of letters, capital letters or small l, small h, capital H. So result is above of or the below the corresponding reference range. So if you will go to the analyzer reference ranges, you will see that we have like a double. We double the ranges with in the middle we have normal limit, and on the outside we have slightly bigger panic limits for each parameter. So according to those data, analyzer will display those letters next to the results. And as you can see, some of those results, they have a small h, there is a small l, but since the PLT range is here, it's actually above the panic limit for the PLT, we have capital H letter. And when there is also a different way of showing or displaying the results on the screen. They use a color. So for normal limit, if something is above or below normal limit, it will be displayed with the orange color. And if something is above or below the panic limit, it will be displayed with a red color. When something is displayed with an exclamation mark flag, the result will be displayed in italic. So as you can see, it's tilted just a little bit. And when the result is rejected with the asterisk signs, or there is a plus, so it's above the reportable range, result is displayed in bold, right? So it will be Maybe it's not visible here, but most likely those letters are bolded. So this was a table for the linearity. Okay, so here we have the histogram for the impedance channel for the white blood cells. And actually, analyzer from this channel can also took some additional information, and those information can be used to generate some morphological alarms. So first alarm which can be displayed is L1 alarm, and actually the meaning of that is a potential presence of the small lymphocytes. Because look, this is actually in this area, somewhere in this area, we should have like a two peaks of the cells and actually nothing on the beginning. And if analyzer will, when analyzer will detect some kind of cells on the beginning of the curve, it means that those cells should not be here in this region. So actually this is the reason for having L1 alarm, because potentially this is the presence of small lymphocytes in the WBC channel. Or this is also a possibility for having some kind of platelets aggregates, or some kind of incomplete erythrolysis. So lysis process was not complete. Or we can have some erythroblasts, which are actually nucleated red blood cells present. So lyse destroyed the membrane of the cell, but it didn't destroy the nucleus of the cell. And in this case, those can be erythroblasts seen by the analyzer in this exact position. But this thing is only displayed when we have some abnormalities on the diff parameters on the scattergram, right? But if we only have abnormalities on the histogram, analyzer will only display the small lymphocytes present alarm. Second discriminator is L5, and L5 is a presence of immature cells. So if the analyzer will display L5, it means that on the back side, the right side of the curve, there are some cells which should not be present here. Usually this histogram looks like, so there is a second curve here, and it's gradually going down, and it's basically disappearing somewhere in the area of the L5 discriminator. But you know, this is possible with the humans. It's not that common to see such a problems when analyzer is sitting in the location where they are only making some kind of screening with the healthy people. But if we have analyzer in the hospital and they are dealing with some kind of leukemias and a different disease, it's you can see such a thing. So you should not be surprised that analyzer is displaying some strange looking histograms, scattergrams, or all those things. Your job in this case will be to figure out also what potentially it's happening, or you can even ask us for help, so we can try to help you to with the interpretation of the results. RBC alarms and PLT alarms. So what we are seeing here, R1 is actually the discriminator which is sitting on the left side, R2 is on the right side. So R1, it means that there is a presence of some small red blood cells. So in other words, microcytes present, right? This is possible. Or another thing, if there is also a PLT P3, for example, analyzer for sure will display the microcytosis, because the red blood cells are also appearing in a PLT channel. As you can see, this is potentially what will be seen by the analyzer in the PLT channel. Microcytes, small red blood cells. Here is an example of R2 discriminator. In this case, the R2 discriminator will be triggered. So macro, big red blood cells, macrocytes, right? So it's shifted to the right. P1, so actually this is the discriminator. On the beginning of the curve, it's usually not displaying, analyzer is not displaying that on the screen. But P1, it's mean that there are some PLT debris or some small platelets. Usually it's not common to see very small platelets, so I believe those are some kind of debris of the platelets or something like that. P2, it's a discriminator actually in the middle. So, sorry, this is the histogram for PLT. So actually, somewhere in the middle, analyzer is seeing the presence of the cells, which should not be seeing here. So this will trigger also the P2, and this will also told you that there is a potential presence of schizocytes. And P3, as you can see, this is end of the curve in this case. So we have a presence of microcytes, small red blood cells, presence in the PLT channel. Okay, morphological alarms related to the diff parameters. So what are those? Those can be right lymphocytes, neutrophil high, neutrophil low, right lymphocytes, high lymphocytes, neutrophil low, neutrophil high, atypical lymphocytes, and immature cells. So this is the region for high lymphocytes, atypical lymphocytes. You see the yellow region. Red one is a right lymphocyte. Neutrophil low is that blue one. Neutrophil high is here, and immature cells region is here. So what are the meaning of those things? If one of these parameters is basically triggered, it means that in the area between, for example, neutrophil and monocytes, right? Neutrophil and monocytes, we have the region where analyzer is also checking what is the number of the cells in this region. So if the number of the cell percentage or the total number of the cell in this region will exceed one of the thresholds, this will raise the alarm for this given area. Right? So in this case, what do you think will be triggered? Neutrophil low, right? Neutrophil low. We see that actually the discriminator, the thresholds is not cutting this thing correctly. So most likely neutrophil low will be triggered in this case. In this case, neutrophil low most likely also will be triggered, and I believe one of the discriminators between between lympho and monocytes, atypical lymphocytes or right lymphocytes, it will be also triggered. For sure, the immature white blood cells, you can see that there is a lot of cells here and also a lot of cells on the edge of the screen. So for sure those will be triggered also. And in this case, this is a blob. I think I took this picture from the leukemia patient. So in this case, it's not even easy to differentiate between the type of the cells. We can only guess if the differentiation is okay, but most likely most of the alarms here were triggered, like everything. High lymphocytes, atypical lymphocytes, neutrophil low, right lymphocytes, IMM, neutrophil high. Most likely everything was triggered here. So the meaning of those things. If one of this is triggered, analyzer is saying, please review the diff under the microscope. If IMM is triggered, is saying that potentially presence of immature cells. Ali, atypical lymphocytes presence. Right lymphocytes, high lymphocytes, please check the lymphocytes. What is wrong with the lymphocytes? And neutrophil low, neutrophil high, neutrophils. There is something wrong with this reading. We also have something like noise regions. So what is noise? Noise one, it's here. Noise two, it's here. So in those regions, analyzer is also checking the presence, how many cells were counted in the counted in those areas, and noise one and noise two, it's basically not the white blood cells, but usually those things will be occupied by platelets. Those things can be occupied by the aggregates of the platelets if we have some kind of clogging, and those can be occupied by the erythroblasts. So this is it. And actually, analyzer can display noise one, noise two, and it will display diff noise. And when the N1 is triggered, analyzer is saying that there are some debris or small cells. And there is additional information if other parameters are triggered. I mean the impedance channel parameters like a L1. Analyzer can also tell you that there can be incomplete electrolysis, erythrolysis, sorry, platelet aggregates or erythroblasts. This is possible. System alerts. So device can display some system alerts. What can be those? First thing is startup failed or startup not done. So it's mean that the startup was failing during the day or it was not done for the daily operation. Unstable temperature. The temperature of the instrument is out of the range. It's out of the 18 to 32 degrees, which is basically used for the analyzer, used by the analyzer. And when the temperature is out of range, the device will not allows the normal user to operate the instrument, and even the biologist account will not be able to perform any analysis because the temperature is out of range. Alarms related to the QC. So QC not done and QC failed. So it says QC not done during the day, QC failed on the last run. So this is it. Another things, and I already talked about these things. So there will be RCL, WCL. Those two things are related to the aperture clock, the RBC or WBC aperture. There is also a WBC balance. So WBC balance is actually a mechanism which is comparing the impedance channel measurements to optical measurement. And when the analyzer will see that there is an unbalanced counting between optical and resistive measurements, analyzer will display this error message or this basically system alert, which means that there is a potentially something wrong in the impedance channel or potentially in the optical channel. So the reading in the optical and impedance channel is not equal enough. Of course, we can have small fluctuation between those two readings, but usually you don't want to have a big difference because this will trigger the WBC balance. Default diff default optical reading unknown. So when analyzer is seeing the impedance channel, but the scattergram, the optical channel is completely empty, this will display the diff default or diff default message, which means that there is no optical reading. So something is wrong with the optical channel. Maybe there is a problem with the blood transfer, maybe there is a problem with the sheeting liquid injection, or the flow cell is clogged or something like that. And here you have the pathologies which are printed only, as I said. So here is the whole list of those pathological alarms. So service menu, I will leave that for tomorrow. And I believe at this point, this is the end of our service training for today. So let me just quickly see if there is no question. No, I don't see any questions. So So if something was not clear during my presentation today, you can always ask your question and I will try to answer them over the WhatsApp chat. Let's see. Yeah, there is one question already. Can we switch the hemoglobin between grams per deciliter to grams per liter? Yes, of course, this is possible. There is a different set of units available on the analyzer, so of course you can do that. This is possible from lab parameters menu and reference ranges. Sorry, not reference ranges. Uh, display parameters. I think this is the menu, and then you can change the settings, and you can have a different units for hemoglobin, and yeah, this is the way. So as I said, please ask your question over the WhatsApp chat. I will still try to answer them today, but if I will see that maybe maybe your question require more time to answer, I will leave it for tomorrow. So I think this is the end of this video presentation, but I will still answer to your question if you will ask some. And I see there is another question related to the flash cleaner. So in case of flash cleaner, the flash cleaning, the bleaching procedure is very, very, very important. If your customer is not running the flash cleaning on the analyzer, of course, analyzer will allows you to run the analysis. But actually, on the every day when the flash cleaning is required, analyzer will display the reminder on the screen that the flash cleaner is required. So flash cleaning is required, and show you something like something else on the analyzer screen. So let me just switch to this thing. So take a look here, and actually I press on shutdown, and usually when the counter for the flash cleaner will not exceed 0 by the number of samples or number of days, usually by pressing shutdown, analyzer is already going into the shutdown. But when the counter is exceeding 0, analyzer will suggest you to perform flash cleaning and shutdown. So actually, this is the thing that need to be performed. Minimum, the minimum number of for the flash cleaning in this case is once per week or every 250 samples. This needs to be done by the user, and we highly recommend to use only the hypochlorite, the flash cleaner, which is provided by us, because you never know what kind of ingredients are included in the domestically available hypochlorite solutions. And from my experience, I know that some customers they claim damage to the parts, and after our investigation we figure out that they are not buying the hypochlorite from us, and from the pictures that they provide us, it was clear sign of damage to the plastic by some kind of chemicals, and actually we reject the warranty claims on those parts. And trust me, it was like a few chambers, so it was few hundred euros for the chambers, for the tubes, for the valves. So basically those people, they destroy like a few good components because they were using wrong flash cleaners or hypochlorite solution. Okay, do we have any other questions? No, I don't see any new questions. So thank you for being with us on the first day of Mythic 60/70 training. Tomorrow we will start at the same time, and the plan for tomorrow will be to first carry on the installation of the Mythic 60. So I will take the latex material, I will have a MITCAL, GCAL, and MIT 5D. We will go through the installation procedure step by step, so you will see how it's done, and I will try to focus on some important part of this installation procedure. And later, we will start with a service training presentation for the Mythic 60. So this is another presentation which is explaining more things related to the technicalities on the analyzer. And I will also try to start Mythic 70 presentation, because 70 is basically similar to 60, but it's not identical. There's some different components, different fluidic system. Analyzer works a little bit different in those terms, and it's a bigger unit basically. So for 70 we need to apply different rules also, and basically you need to understand how device is performing the analysis, and the analysis is performing the same way, but is done faster. So there are some stuff which allows the 70 to perform this analysis faster. So thank you for being with us on the first day. I hope you already gained a lot, and I'm very happy that some of you take your time and you try to answer to my question over the quiz. And as I said, some of you already have few extra points for the test, so it will be easier to pass the test later. And by making this quiz, we try to have you more involved in this whole service training. And just let me know over the chat, what do you think about the quiz, if this is like a good thing or not. And I believe in the future we'll maybe introduce this quiz as a normal thing for the service training. Okay, have a great afternoon, and see you tomorrow morning. Bye.
We see ourselves as a lifeline which connects doctors, diagnosticians, and patients with cutting-edge IVD technology. We provide medical solutions to make your healthcare better. It all started in 1985 in Poland when Korme had its beginning. Since then we have been striving for a better, healthier world. Next, in 2001, Orphe joined the world providing advanced hematology equipment. In 2005, two brilliant teams became one, like two rays of light focused on one lens. Over the years we have helped more and more people throughout all the world with the access to reliable tests and high-performance IVD technology. We refreshed our brands to emphasize our common goal. We are constantly expanding our portfolio to help you with a wider range of challenges. We help doctors, lab technicians, IVD experts, and foremost, patients, to deliver positive health outcome. All of that led us to become one. Korme Diagnostics, the lifeline to better health.